So we systematically came up with 8 group orbitals using symmetry. Those 8 group orbitals that we came up with are the same as the 8 group orbitals that we imagined with pictures. So let's attach the symmetry labels that we derived from group theory with the pictures that we had in mind. So when we thought about the two s orbitals, we came up with an AG group and a B1U group. We can see that the one where they're both unshaded, this is the A1G orbital. Note, it's common when we write the symmetry labels of orbitals or molecular orbitals, we often use lowercase, just a convention. So we know that this is the A1G because it is symmetrical. In particular, it's symmetrical totally, but it's also symmetrical specifically with respect to inversion. If you invert through the carbon atom, that group stays the same. That's not true for the B1U group. So we know the other group has to be B1U. And we can tell it's U because if we were to invert through the carbon, the shading would change places. So it would be not symmetrical with respect to inversion. For the group of 2px orbitals, we have a B2G and a 3U. And we can kind of do the same thing. We see that this first combination must be the U combination because it's ungerada, it's not symmetrical with respect to inversion. And the other one is B2G. Okay, for the group of py orbitals, we have some different labels. Once again, we've got a BU, B2U in this case, and then this one must be B3G, this other one here. Okay, lastly, for the combination of the PZ orbitals, we've got the same as for the s orbitals. We've got an AG and a B1U. So this first one, not symmetric with respect to inversion, must be the B1U combination. And the second one, which would be symmetrical if we inverted through the carbon, must be the AG combination. Now, let's think about how these orbitals would match up with the symmetries of the orbitals on the carbon atom. So the s orbital is always the totally symmetric representation. So here that's going to be AG. The px orbital has the symmetry in this point group of B3U. The py orbital is B2U, and the the pz orbital is B1U. And where do we get those? We get those from that third column on the D2H character table. Okay, so when we do that, we see that we're going to make some matches. We see that we said that the s orbital could match up with the group orbital where they're both unshaded or where they're both shaded. And so we see that, look, they both have the symmetry label AG. We see another AG combination that comes from the combination of the PZ orbitals. And look, we have, with the two s orbitals, we have a B1U combination that's the same as the B1U from the PZ orbitals. So we see that we get all of the same pairs that we predicted by just looking at the orbitals, but now we have come up with them systematically. Note that nobody matches, none of the carbon atomic orbitals match with the group of either B2G or B3G. Those don't have any orbitals to bond with. So we're going to find out that they're non-bonding orbitals, orbitals that will stay the same as their atomic orbitals.